Hi, I'm Ed. Welcome to Common Sense.
And I'm John, and welcome again. So today we're going to talk about disruption, but I wanted to sort of circle back to why we're here. Thomas Paine is our inspiration. He's the guy that wrote Common Sense in Revolutionary War times to inspire the people and the soldiers to change themselves, to rise up against tyranny. And so back in 1776, some important things were going on at this time of the year, particularly this day. So I'm going to put you on the spot, Ed. Do you know, you're a history buff? What was going on back in 1776?
Well, I am a history buff. I don't remember all the little details. Fortunately, shared docs means I got to see your notes before we got together for this call, though, John, so I had a chance to look it up. This was actually around the time that Thomas Paine wrote his famous quote about these are the times that test men's souls. And if I understand correctly, that was kind of as there was this exodus, people deserting the Continental Army, giving up hope. It seemed like a hopeless cause. And of course, in a week, Washington crossed the Delaware and executed a brilliant battle plan and won a stunning victory that kind of turned the tide of the war. And so it's, an interesting day to be talking about disruption, because in so many ways, these times seem to test our souls as well. It seems like we're going through a lot more disruption than other people have, but that's probably just perspective.
No, you're exactly right. And I think the article he wrote, American Crisis, is really reflecting, like you said, in our times, we're going through crises in a lot of different ways, and technology is one of them. So I think it would be appropriate to talk about that and how change and the power of the pen and all these things can really be brought to bear on what we're looking at today. So why don't we start there? What's kind of your overall perspective on how technology is changing us? And then we can get into some specific cases and ideas that we both like.
So I think from a business owner perspective, or just as a student of history or watching current events, the hardest thing is to discern the noise change from the signal change. And what change really is making a difference. Facebook, how many times have you heard it was or it wasn't the change? It's just part of the background noise, or it is the kind of signal change of social media and the way we interact. And I love the example, and maybe it sets good context for this conversation, the example from Machine Platform Crowd, where the authors talk about electricity coming into the mills. Mills were built by rivers because they were hydroelectrically powered. So they built these vertical buildings with these leather belts that transmitted power up through the building and down through along the floors to each of the machines. And so electricity was invented. And in retrospect, we say, well, electricity changed that. We didn't need to build by rivers anymore. Except the interesting thing was, electricity was introduced as these huge central power plants in the basement of the factory, just like the hydroelectric generator was. So they still had that same model of vertical buildings with leather belts transmitting power up to floors, and then horizontally along floors down to each machine. And the real revolution happened when somebody realized that they could miniaturize a motor and distribute the power, put a motor on each individual machine. So we think of electricity as being the change that mattered, and certainly, it was a precursor, but the change that really impacted manufacturing was the distribution of power. And so it's really important as we talk about some of the disruption that we see to say, okay, is this the one, or is this just a symptom, or is this an indicator? What's the real one, and how's it really going to impact us over the next 5 to 10 years?
Yeah, and it's amazing that these revolutions are happening in really every industry and every aspect of life. So I thought I'd start off with kind of one of my favorites, and that's transportation. We've all probably read about driverless cars or trucks, and it's interesting to me because everybody sort of goes, yeah, that's an interesting sort of hobby, but it'll never be commercialized. You'll never have cars that are free of drivers and trucks and so on, but it's already happening. And, it won't be long before this is really kind of becoming part of our economy, I think. And then we see headlines like this last week where SpaceX has successfully landed several of their capsules for commercialized space travel. So within a few years, in fact, next year, they're talking about sending some people who have more money than you and I do around the moon and back. So, even going back into space is becoming a reality because it's being privatized. And then maybe one more that I thought not everyone has heard about is also from Elon Musk, and that's the Hyperloop, which is it's an interesting concept for city-to-city transportation that's very low powered. It's actually a tube where you have we've all seen these pneumatic tubes where letters used to fly back and forth between offices, being sucked from a vacuum. It's the same idea, only for commercial transportation, where you have cars that float on magnets and are basically sucked from one end to the other. And it's extremely sustainable. It's very low power. It's very fast. You could theoretically get from, say, Boston to Washington in a couple of hours. And everybody thinks, well, this is never going to happen. There's no way the economy would support it. But Elon Musk and his crew are actually building one in Dubai right now. And they're talking about putting one in California within a few years, and probably the East Coast. So the impact of that is amazing if you think about it. It could really save a lot of energy, a lot of carbon footprint, of course. But it could also be very economical. It could relieve a lot of the traffic problems we see in our cities today. It could make us more efficient. There's just a lot of different things that something like that could do.
And the driverless cars, if I'm always at the airport, I enjoy sometimes a road trip. It's kind of a cathartic experience to get behind the wheel and drive. But I'm not one of those people that really loves to drive. And I think about what would happen. We see that there was this trend to remote working that now is reversing. More people are in their offices. More companies are expecting people to show up and be at the workplace. And there's a lot of value to that collaboration that happens there. But that means more people are wasting more time commuting. And what if, I've seen numbers, I don't remember what they were, but mind-boggling numbers, the number of hours that are spent every year commuting. And if you could unlock productivity during that time, even if it let people sleep, so they work later at night or had time with their families or something, or if it let them do some work, or if it let them learn. Right now we can listen to podcasts while we're driving, but if you could actually engage in interactive learning during that time, the opportunity to just create riches in all sorts of ways for us by using that time that's spent driving cars it's amazing. You think about the implications of it. That's wild.
Yeah, and eventually you could get rid of highways, and you could get rid of parking lots, and you could get rid of pollution from cars. And, there's a lot of spin-offs from something like that. So
cool.
It's happening again. It's not a dream. So stay tuned.
Well, another thing along those lines that's happening now that's, sounds a little bit science fiction, but it's not, is Internet of Things. And what I find is that when I talk with people about IoT or IIoT, the industrial Internet of Things is kind of the world in which I'm more active, they tend to think in terms of sensors. And I think the really smart people in this area see the sensors as just a piece of hardware. It's kind of a facilitating technology. The power of IoT is in the data. And the way that data can be used to improve the performance of a function or a machine or a process, the way that data can be mined to find efficiencies, the way if a company owns data, if say a company manufactures machines and has access to data, offers product as a service offerings that incorporate monitoring and allow them to collect data in the process of it and aggregate that data, even if it's anonymous, to protect the privacy of individual user locations. Still, that aggregate data offers incredible opportunity to mine it for insights and understand how to find additional operational efficiencies that an individual location might not be able to uncover on their own, but with the power of that data in aggregate is incredibly powerful. So when you start to think about the lead that some other countries and regions have in this area, It's fairly well acknowledged in my experience that Europeans are more advanced in IoT than American manufacturers that are tending to think about the technology of the sensors rather than the ecosystem. You look at some of the stuff that Bosch has done, and it's really amazing in that in the sense of that ecosystem of how IoT can work. Of course, it's not just in industry. It's not just IoT, it's IoT as well. I've seen some really fascinating examples with a company called Ira that uses Google Glass for people with limited vision, blind or low vision people that need to navigate tough situations where, you know, having a cane and having experience and having all their savvy may not be enough. Crossing a busy street in a snowstorm with snowbanks and ice and puddles. I mean, you can put on Google Glass, somebody is your eyes for you and talks into your ear and tells you what to do. It's really cool. So there's a lot of stuff going on in that. Of course, you know, again, the implications, what will it mean? How will it change industry? That's where we maybe want to go out on a limb today and make some calls. You have any projections you want to make?
Well, again, it's interesting what you brought up, that the U.S. is kind of lagging in this area. We might not be lagging in the technology development side of it, but we're not really implementing it like other countries are, like you mentioned in Europe. The Asia Pacific countries, they're spending 1/3 of the world's budget on IoT, and they're strongly in manufacturing. So they're way out in front in really actually using IoT for lots and lots of different things, from facility management to safety and security, logistics, quality control. I mean, everything you can think of that goes on between a manufacturer and a customer is really going to be monitored by IoT nowadays. And all that data is going to be really important for making changes, you know, and making updates and being more efficient. So the big benefit to manufacturing is, you know, there's lots of them, but efficiency is huge. Competitive edge is huge, you know, all of those things. So
I think the biggest risk for manufacturers is if they don't pay attention to it. First of all, they're going to kind of get left behind. They'll be selling what's essentially a commodity in the machine or the product, because the real art, the value is going to be in the comprehensive data and understanding of the application. But second of all, I think the companies are going to see defections. They're going to see talented, young, energetic employees that see opportunities to use this kind of stuff, that keep going after management saying, let's try this, let's try this, let's try this. Management says, oh, no, it's not going to happen. You know, it's hundreds of years away. We heard about this with you know, such and such in the past, and don't do it. And I think a lot of these talented employees are going to defect, go and start their own businesses, be tremendously successful on their own in some cases, of course, you know, fail in other cases. But I think that companies are going to lose talent because they don't embrace some of these interesting technologies that a lot of their folks are going to really want to be working on.
yeah, talent's a really interesting topic too. So we'll hold off on that for a little while, but it's huge impact of all this automation that's going on. It's not so much finding talent, but what to do with people, period. Right. So let's move on to 3D printing now. I think that's one that people have some misconceptions about. You know, most people think it's still just kind of a hobby. It's something that's new, and it's, you know, we're just kind of trying to figure out how to use it. Not true at all. It's way more than a prototyping or design tool now. GE, for example, has a whole plant that does manufacturing based on 3D printing. It's true that, you know, like 57%, I think, of all the work that's done is still in the first few phases. But that has a critical impact on every part of manufacturing, because you're getting the design right in the first place. You're able to test out different things. You're able to QC it. And you're able to be far more efficient in your line manufacturing once you get, you know, the right prototype. So it's having a big impact across all kinds of industries, not just manufacturing. And 90% of the companies that use it are saying that it's already a huge competitive advantage. So it's catching on very, very quickly. Again, it's primarily in other places other than the US, so we kind of need to get going with that.
Yeah, and GE built that 3D manufacturing center in Germany.
Yeah.
One of the misconceptions that I see is that what 3D printing allows you to do is construct the same piece that you might have gotten from a machine shop, but do it with a different technology. And that overlooks a lot of the potential. You can actually build structures that you couldn't possibly machine, that mean that they're lighter or made with different materials or constructed in ways, that are not symmetric, that allow it to actually work in an application better than you've been able to machine it. So there's actually things that you can do with 3D printing in addition to reducing waste, because it's additive rather than,
Right.
subtractive and taking away the other stuff. So it's got amazing potential. I wonder sometimes when I speak with people in the industrial world, I say, what if 3D printing really has the potential that many smart people, not crackpots that are dreaming up their own science fiction world, but smart people involved in business, if it has that potential, I mean, it means we don't have factories. And if we don't have factories, then we don't have logistic systems. I mean, imagine if Walmart became a big lobby that had machines like the Redbox video machines. You put in your credit card, punch in the code for what you want, and it prints it right there. And all of the whole distribution manufacturing system becomes irrelevant at that point. I mean, it's a really a very different way of looking at the world, and completely disrupts a lot of what we just get out of bed in the morning taking for granted.
Yeah, and the whole time, the time from desired purchase to delivery becomes way shorter too. I mean, you can even imagine having on-demand systems that you just get the product as soon as you punch the button.
Patches of one. Everyone
Yeah.
talks about customization, personalization. That is the ultimate personalization.
Right. And now they're thinking about that in terms of everything you can imagine, from food to drugs to, anything you can imagine. So
My sense is that food will probably be last. I mean, I think that if you told somebody they're eating a bowl of 3D printed soup, and I'm not saying anybody has even figured out how to do it yet, but it just feels a little bit strange. If I'm using a 3D printed screwdriver or wearing 3D printed shoes, or even eating with a 3D printed fork, I mean, that's okay, but actually putting the stuff in my belly, it feels a little bit odd. And so that's probably the last frontier, if you will. But a lot of the kind of staples that we think of, I mean, they've printed organs and skin. They're
for
printing
sure,
biological things.
certainly in medicine, it has lots of potential.
Right.
But it kind of does make you think about Soylent Green a little bit, that we may be the food eventually.
Right. Well,
that takes us to AI, which is another huge leap forward. But that's been, we've been working on AI since really the 50s, if you think about it, machine learning and things like that. But it's now becoming not just possible, but it's, as we've talked about before, it's really spreading like wildfire, that people are using artificial intelligence for all kinds of automation, all kinds of maintenance, all kinds of predictive things, and reducing errors and reducing costs because you're getting it right the first time, or you're intervening before things get out of hand. There's just all kinds of things that humans aren't adept at in terms of, analyzing, making quick decisions, knowing exactly what to do in a split second. All of these things are AI strengths that, we really ought to be embracing and not afraid of.
but of course, it's the availability of data. There's a couple things that have happened. I mean, of course, AI has been a concept for a long time, but there wasn't the computing power to crunch the volume of data in the way that was necessary. And now that's available, or becoming increasingly available. And the volume of data that's necessary to really make extract the insights hasn't been available. And IoT, along with other technologies, means that there's more and more and more data. So there's more of that material for this increased computing power to massage and manipulate and extract those insights. So it's a lot of this stuff is advancing simultaneously because it's kind of building in this symbiotic way upon these other technologies too.
That's right. And it's becoming very cost effective to make these investments too. I read some data that this type of technology has led to 81% reporting, reduced costs and increased revenues, 76% report error reductions, 95% report better customer service. So, I mean, these are not small impacts. These are huge numbers. And, it's becoming to the point where if you're not embracing AI and other types of automation, IoT, robotics, and so on, you really are falling behind and you're not taking advantage of these economic benefits.
And for talking about talent, for young people wondering what field to go into, as much as the potential of AI excites people, there's a dearth of engineers that really understand it. I mean, that becomes a bottleneck, the folks that can do it. But there's, we tend to think of these heavy analytical tasks, business finance and detecting fraud or anomalies in accounting, some of those kinds of things. But there's other stuff associated with it. Machine language translation is an enormous opportunity. It could essentially eliminate borders in commerce. I mean, you could go on to a digital e-commerce platform, and regardless of what language somebody loaded the product information in, you see it in a language that's entirely native and comfortable to you. And you even see some of the details, sizes that may be in metric versus SAE, just kind of fluidly translated without anybody being involved and without error. So there's opportunities not only to extract information from data that we couldn't, but to perform functions that we've never thought could be adequately automated.
That's right. And it's really not an exclusive thing, to robots and other machines. If you think about it, if you can design intelligent machines that do what they do extremely well, but can also work side by side with a human, then you can take advantage of the talents that humans have that machines really have struggled with. For example, recognizing things and having some sort of emotional connection with things or people. So I think when you start to think ahead as far as how we're going to adapt to this new world of machines and AI, we really need to think creatively like that. How can we work together with these machines rather than being afraid of them and running away from them?
So that your talk about robots or cobots in the case of working together brings us to another big section of technology that people are often talking about. That's robotics. And obviously the advance of robotics has been amazing, from what we saw that was really gee whiz stuff, particularly early on in the auto industry, that would pick up some heavy elements and weld them together and help manually assist with some of the manufacturing. I mean, it's incredible progress in robotics. And I know you've done a lot of research and have a lot of great stats and information about robotics.
Well, just in the last 10 years, the market value of robots, industrial robots, has tripled. So it's really growing fast.
And that's as prices have come down. So that's like probably a tenfold increase in penetration.
That's right. And it's mostly been in the IT or the technology sector so far, in electronics, but it's growing really fast across the board in all kinds of manufacturing, not just automotive and electronics, but really anything you can think of. So, if you think about it, the advantage that robots have is that they can do things endlessly and repetitively without making any mistakes, which is something we're just terrible at. We don't have that kind of stamina. We don't have that kind of ability to focus. We can't adjust ourselves, that at that scale, without making mistakes. So they're great for all kinds of repetitive things. And again, if we can work together with them so that we leverage our creative side, our right side of our brains to help the left side, which is now a robot, we could be a lot more effective than we are now.
And so there's some hybrid models too. I mean, I've seen some interesting applications of exoskeletons or kind of partially robotic stuff. I mean, one great application I saw was people working in a shipyard that had to have particular welding and grinding skills in order to make sure that these these complex multi-layered hulls were properly configured. But that means holding 75-pound grinders over their head for hours on end, doing this precision work that you really need a person with that intuition expertise to do. And so by using some sort of a quasi-robotic exoskeleton, they're able to take the weight-bearing and physically exhausting and dangerous elements out of it, let the system bear that weight, and let the human bring the expertise to it. There was a great example last week as well of a company that's intent on bringing AI to manufacturing that has as one of their early examples a chip inspection system. So they're using not just inspection against a known good part, but they're using AI to easily identify what's a good part versus a bad part, and then perform this inspection system with a robot, essentially with a camera. So blending those two technologies together in a way that relieves people of doing a dreadfully boring and tiring job. It's not physically taxing, but it's certainly tiring.
Yeah, and if you think about it, anything that's hazardous to humans is a great place for a robot, like going into a nuclear plant that's melted down or something like that. There's been some amazing stories from the Japanese disaster about how they managed to get all that nuclear waste out of there using robots. And mining, as long as mining still goes on, they'll be using robots nowadays. But it's not just industrial too. You think about it, right now they're rolling out these ordering machines at McDonald's and other places so that you don't really need a human taking your order anymore. And here in Houston at the Texas Medical Center, there's surgeons, cardiac surgeons, eye surgeons, all kinds of surgeons using robots to do the really fine, delicate work that a shaky hand just really can't do very well.
Right.
So it's amazing just how many opportunities there are to improve, all kinds of outcomes using robots.
And probably the last area of robots we got to talk about before we move on is drones.
Yeah,
drones are something we start talking about delivery and logistics and I mean even photography hobbyists. What's happening with drones is amazing right now. UPS has a patent on a van that goes out that allows drones to launch from the van and return to the van. And Amazon just got this patent for self-destructing drones in case they're flying someplace and they get into trouble and they don't want to crash into a crowd, so they self-destruct the drone. I mean, there's amazing stuff going on in the drone world.
Yeah, it probably won't be long before we have humanless wars too, which is kind of a scary concept. But at least the rich side of the fight will be, largely automated, I would think, in the coming years, and it's already to some extent like that. But
this raises this whole this concern about this dystopian world where there's no work left for anybody. And what do? We've improved our lives because we don't have to do these unpleasant or dangerous or dirty tasks. But if all the thinking and all the working is done by machines, then what's left for us to do?
Yeah, we really have to think about that. And, for an old dog like you or me, if we were on a line in a manufacturing plant, I don't know what we would do. We'd have to think about something that's not related to manufacturing, probably, unless we had the ability to go back and learn how to work side by side with robots.
Actually, an interesting program Massachusetts announced this week is going to use empty voc tech schools to take lower skilled manual workers and train them in advanced manufacturing techniques. Now, 3D printing means the runway for that may even be relatively short. And if I was running a machine shop, I'd certainly be thinking about how I could develop 3D printing capability and short runs and all that kind of stuff. But that understanding how to address that employment piece of it seems to be the biggest challenge that we can't solve with technology. That's going to require really thoughtful sociological and philosophical exploration of where we're going.
Yeah, we have to rethink education, like you said. I think, even now you're seeing a lot more colleges offering more coding classes and more technology-oriented career paths, which makes a lot of sense. That's really, if I were a young person, that's where I'd go.
And there was a neat program, I think in West Virginia,
Yeah.
where folks coming out of the coal mines that were losing jobs in coal mines got trained in coding. I forget who was running that program, but tremendous results with it.
Yeah. Or the other thing is, think about what machines aren't very good at. And they're not very compassionate. They're not empathetic. They're not good with working with people necessarily. They don't really sound like people yet, and they don't make us feel good. So we're still going to need people in healthcare. We're going to still need people in any kind of luxury industry where we're just catering to ourselves, basically. I mean, you can think of a lot of different things like that. Like you said, I wouldn't want to eat a 3D printed hamburger necessarily. Certainly not a high-end steak. So you're going to still have chefs around, I think. And you're going to have poets, and you're going to have priests, and, there's going to be people that do that.
Right.
So, if you're not inclined to write code, there's still hope for you. Although not much.
All right, so moving on, next area of disruptive technology. How about we talk about blockchain?
Yeah, that's certainly been in the news a lot these days. Everybody's talking about Bitcoin, of course. Everybody thinks that blockchain and Bitcoin are the same thing,
Right.
and they really aren't. Bitcoin is just a use case of blockchain. Why don't you explain a little bit about that?
So most people are familiar with it. Just real quick, what blockchain does is essentially creates a record, and that record is replicated in countless places around the internet, so that even if you were to try to fraudulently modify the record in one place, this mirroring in all these other locations would quickly reveal the fact that that had been fraudulently modified. So what that means is you've got security of the data. And so if that data is used, for instance, to indicate ownership, if you've ever bought a house and you had to pay money for a title search, and you had to pay money for title insurance in case the title search missed something, that's a perfect example of where if we really could follow in a very sequential and publicly fraudulent proof way the history of ownership, then you wouldn't even need to do a title search. You wouldn't need title insurance. If you think about 3D printing, one of the considerations people worry about is, well, what prevents counterfeiting? Or what prevents people from, even if it's not counterfeit, if they take an original digital file and make their own part, then who owns the IP? I mean, who designed that part? Who owns the final product? So if you could have blockchain that would authenticate the ownership of that original file and carry with it, the obligation for payment, so that you couldn't actually access the file and use it to 3D print something until it had been paid and that had been properly documented and replicated around the internet, you suddenly solve that. So OEM parts, for instance, if you wanted to make sure that you had a genuine OEM part for replacement or whatever you were doing, that would be a way to do it. A lot of the interesting applications, people tended to focus in finance originally because there's so many opportunities for fraud and so much incentive for fraud working around financial stuff. Plus the fact that the first well-known use case was in finance with Bitcoin. But there's a lot of work around using blockchain and logistics to make sure that, is this stuff that was shipped the original stuff? Has it been tampered with? How's it moving through the process? Where is ownership transferred? How is customs handled, or how is compliance handled with product that's moving internationally? In fact, UPS made a splash this week when they signed on to the Blockchain Logistics Association effort. I can't remember the formal name of the group, but UPS has really gone in on 3D printing a while ago and blockchain now. So it's a technology that has much more kind of ubiquitous potential to impact our lives than we tend to think about where it's associated with Bitcoin, as you say.
Yeah, I've seen it talked about in terms of medical records, transferring, your medical data back and forth between your doctor and and leaving out the insurance company, leaving out the hospital. So that's one of the key impacts, I think, is sort of cutting out the middleman. And people are concerned with central banks being corrupt and getting hacked and all that sort of thing. So, that's a problem that it may solve. And then, if you think about it, really any kind of private communications could be secured this way. and that would solve this huge security problem we're all seeing with all kinds of digital transactions now.
But you think about how much overhead is embedded in transactions to pass paper and stamp it and authenticate it and notarize it, and all these different things that are done in order to try to confirm that the original owner or original intent is actually followed through. And
sure,
because that's embedded, in many cases, we don't really understand the true cost of that because it happens sequentially at different steps through the process. But potentially you start to eliminate that. And that's like unlocking huge opportunities, almost like if you could use all those hours spent commuting. That's got that same kind of potential in ways that people may not necessarily think about immediately.
Yeah, and a lot of people hate regulations too. So if you could cut out the regulations and the compliance, all the time you spend on that and money, just by going point to point on every single transaction, who knows? I mean, that,
right.
That could be big too.
Speaking of big, AR. I think VR probably makes a bigger splash, but AR feels to me like it's got more immediate applicability. What are you seeing with AR?
I haven't seen a lot of it yet, but I've certainly read about it. It's pretty big in marketing right now. So the idea is that, you're trying to show a potential customer a product, and with AR, you're able to give them more of a guided tour online and more of an interactive experience. So for example, you're looking at a car and you don't actually have to go test drive it. You can actually do that online and, feel around and see how it looks and explore and that kind of thing. So it's becoming a big thing. And it's, like you said, it's not just VR. You don't need to have this immersive experience necessarily to explore and find out more information. So it's applicable across anything you can think of that has that scenario.
So speaking of marketing, a really interesting application for AR, and so let's just back up. VR, virtual reality, AR, augmented reality, and virtual reality is kind of like going into this science fiction world. You put on goggles and you're floating or whatever is happening around you. AR, in many cases, you put on glasses, but those are smart glasses. And so you go into a trade show booth, and let's say that everybody's busy, or let's say you don't want somebody hassling you. You want to just take your time and move around yourself. Well, you put on AR glasses, and as you look at something in the trade show booth, you get some information in the glasses. Maybe it gives you background on what's going on. Maybe it tells you what it does. Maybe it knows who you are, or maybe you give it information up front about the business problems you're trying to solve. And it says, okay, this will help you solve those business problems this way. So it can almost be like a guided tour or something. That also works really well when you start to talk about training, particularly in the industrial world, and machines and capital equipment, training operators, doing changeovers. Changeovers are a source of inefficiency and downtime. If people could put on smart glasses with AR to talk them through the changeover, follow a sequence of steps very efficiently, look over here, that's the knob, turn that knob to this number for this setup changeover that you're doing, that kind of stuff could be really cool. Plus, of course, training maintenance and operators, and even helping with remote diagnostics. You're looking at something, you're standing there in front of a compressor, for instance, and it's making a certain kind of a noise, and you're looking at the section where it's making noise, and the smart goggles will start to give you information. Check this, check the voltage here, make sure this seal's good. By the way, if it's not, here's the part number. You can order it by clicking this link and get the part sent to you by drone or 3D printed in your maintenance shop, or however advanced this becomes. So it's really about replicating a lot of the kinds of things that you'd have to do with somebody standing there. You can now do remotely or by designing the AR system.
It sounds like there's quite a potential for crossover with AI, I would think. If you had an AR experience that's guided by some intelligence, that's kind of everything you need.
Absolutely. And then with IoT, so if people are doing these AR experiences, and what you find by watching the data is that they tend to focus in a certain area, and you accumulate that through the Internet of Things connections, and now you use AI to mine that data, and you say, you know what, for some reason, this is an area of primary focus, so let's research it. Let's see if we need to improve this or train on it more or simplify it or whatever the case may be. So all of these technologies absolutely begin to fit together in this ecosystem of disruption.
Wow. Well, let's talk about one that's kind of last on our list, but maybe way out there in terms of people understanding what it is. Let's talk about DNA tagging. So what exactly is that?
I think it's really, really, really cool. If you look at supply chains and the opportunity for fraud and counterfeiting, the numbers on counterfeiting of food, even domestically in the U.S., are astronomical. And if you go on eBay to buy something, if it was any sort of luxury or Western good, the risk is very high that you're going to get something that's counterfeited. You start to extrapolate this out, and you look at pharmaceuticals, or you look at the organic foods that you want to consume. You look at a great case study was cotton sheets. There was some major retailers that were selling quote unquote Egyptian cotton sheets that found out that the cotton that was being supplied to them by very reputable vendors was in fact not Egyptian cotton. And that actually prompted some of the development of this DNA tagging technology, which now is used, for instance, if you're building weapon systems for the US military, it's critically important that the control chips be genuinely manufactured in the controlled facilities in the US, so that we're not using control chips that are actually manufactured with, built-in backdoors and monitoring or tricking technology somewhere else. But I mean, how do you know? You can put a holographic sticker on it, you can do all different kinds of things, but none of those are really as secure as people think they are. You can put DNA on there, and that DNA is such a specific string that's controlled in a way and checked in a way that you know for sure. And it can't be fraudulently replicated. So this stuff, it can be put in lubricants on metals. It can be extruded in plastic. It can be added into agricultural products, so that from the time it sprouts out of the ground in the field until the time it's consumed, you know exactly what it is. So imagine, start to think about, for instance, if you're eating organic food, the food product itself could be DNA tagged. The packaging material that's designed in a certain way to guarantee a certain shelf life could have a DNA tag extruded into it, or into a glue layer between layers of a lamination. The box in which it's put, or the stretch wrap around that, which is used to transport it from the manufacturer to the retailer, could have a DNA tag. So you can very quickly eliminate a lot of the places where traditionally there's been theft or risk of counterfeiting. It's really fascinating technology.
And you could just source anything from, let's say, have a complex product that has lots of different components. You could track every single one of those independently and find
Of
out
course.
where it was manufactured, how, when, just anything you wanted to know.
And with complex supply chains, I mean, that's not just a pipe dream. That's a real world logistics consideration.
Yeah, amazing world we live in, huh?
It is, absolutely. And so the trick is, for businesses, how do you decide which of these changes are going to impact you? Which are going to impact you in 12 months? The great quote, I've heard it attributed to Bill Gates, but I think it actually came, I'm forgetting who it was before that, but we tend to overestimate the change we're going to see in the next couple of years and underestimate the change we'll see in 10 years. And so which of these changes are really going to impact the way that we're working? What do companies really need to be thinking? Not just in this incremental way, here's our business model today, here's our product or service today, let's add another feature or let's add another sensor or something to it, but really kind of mind shift. Maybe you don't build the business model, but at least begin to think about it and anticipate how you might react, and watch very closely and understand what's happening in the market so that you're not obsoleted and surprised.
Yeah, and you have to be aware that these things are not just fantasies anymore. They're not just things you see on the Discovery Channel. They're real, right? And they're being implemented by your competitors, a lot of them overseas. So if you're worried about that, then you ought to be worried about technology.
That's a great point. A lot of the overseas competition that we tend to think of as low quality, low price has moved beyond that in many cases.
Right, and it's complicated too, right? Most products that are made anywhere have components from overseas.
Right.
So it's not just, that you might be the weak link in the machine if you're, not getting on board with these things. So,
right.
Well, that's great. So I think we've touched on a bunch of different subjects today, and the bottom line for me is really we shouldn't be afraid, of the future. We should really embrace it, and we should really start thinking about how we can individually take advantage of technology as well as improve our lives, improve other people's lives. So a lot of this ties together, and automation is something that's coming. It's unavoidable. So start thinking about how you can take advantage of it rather than just run away from it.
Cool. Well, it's been a great discussion, John, as always.
Same to you, and Merry Christmas and Happy Holidays to all of you out there. And we'll be back after the beginning of the year.
With more common sense.
Thanks.